Okay, good afternoon again, everyone. We're still on transformation. We said there are different types of transformation. We went through translation, and we learned about how to describe in a translation using vector. And we said that's a slide of an object or object point to create an image. We went through reflection, which we flip an object or object point to create the image through a mirror line, right? To describe a reflection. Today we're going to learn about rotation. Today we're going to learn about rotation. Okay, a rotation is a transformation. So another type of transformation is a rotation, which is a spinning of the object. When we talk about object, we're talking about a shape: rectangle, triangle, trapezium, any form of shape on the Cartesian plane. So a rotation is a transformation in which an object or object point, or the points on the object, is turned a given angle and direction around a point, which is called a point of rotation. So what we are saying here in this definition, when we are describing a rotation, there are three concepts that must come out in your statement. If you don't use these three terms or concepts, you will not get the full marks. So you must describe the angle in which the object is turning: 90 degrees, 80 degrees, 270, 45. The direction, is it going left or right? But we learned that we won't use left and right. There are some new terms that is associated to left or right on the Cartesian plane and around a point. Is the point of rotation at the origin or any other point on the Cartesian plane? Example 2, 5 or -1, -3. So the point can vary. Okay, so we're going to learn about rotation today. Remember, there's no one method of doing mathematics. As long as you're showing procedure and you can apply your skills to real life, then you're on your way. But most importantly, our prior knowledge we must recall so we can transfer learning from one topic to the next. We don't learn in isolation. All topics are connected or linked in some way or form. So one concept we must recall is point. Point, once you're doing graph, is a set of ordered pair, the x and y value, right? Coordinates, okay? Direction in terms of left and right. But on the Cartesian plane, say we are using the 0, 0, the origin, as a point of reference. Like the hands of our on the clock, on the Cartesian plane, when we move to the right, or when we rotate to the right, the concept that you'll use is clockwise rotation. When you rotate to your left, the concept that you'll use is anti-clockwise or counterclockwise. So clockwise to your right and counterclockwise to your left. Remember, it's just a point of reference. A point can be anywhere, but we still move right, which is clockwise, or we still move left, which is counterclockwise or anti-clockwise. Okay? So point, direction. Another concept we must recall is angles from where we're doing construction. So point of reference, if we rotate here, going clockwise, it's 90 degrees, 180 degrees, and so on. And if we're going counterclockwise, we still get 90 degrees, 180, 270, 360. And you know that there are values that may fall in between, like 45 degrees, 20 degrees, 30 degrees, because we did all that in construction. And finally, but we must remember bisecting straight lines. And additionally, a skill that we should also recall when we're doing rotation is that if I rotate 90 degrees clockwise, it's the same as rotating 90, 180, 270. So 90 degrees clockwise is the same as rotating 270 degrees counterclockwise, because we'll end up at the same position. And if I rotate 180 degrees clockwise, it's the same as rotating 180 degrees counterclockwise. Some skills we should play around with. Okay? Instruments that is required for this subtopic: rotation is a ruler, protractor, and compass. And remember, I'm just using a method. There are other methods to do rotation. A capital letter R is used for rotation as a notation along with other symbols, but as basic rotation, we say that R is used to represent rotation. Let's do two simple questions so we can understand rotation. All right. Okay, let's look at this question. Determine the image of a quadrilateral. So every concept, every word in the question is important. That means we're going to get a four-sided figure, W, X, Y, Z, with coordinates W 1, 4, X 4, 4, Y 4, 6, Z 1, 6, under a clockwise rotation 90 degrees. So we're going to our right, 90 degrees, about the point. So we must have these three things. So we want to determine the image. So we have given the object point, the direction, because the word clockwise tells us we're going to go right, the degrees we're working with, and the point of rotation. Okay? All right, preset or point of rotation is 1, 1, point P. So here we have already done our point of rotation, 1, 1, 1 to 1. Okay, and that's P. Now let's draw our other points. Let's draw the quadrilateral double. So we have 1, 4, 1, 4. We have 4, 4 for X, 4, 4. This should be for X. And then we have 4, 6 for Y. And then we have 1, 6 for Z. So we have our 4 points for our object. We can connect our points to create our image later on, but this is our object. So this is our quadrilateral for our object. Now they are saying that we must determine the image. Now this is one method of doing rotation. From the point of rotation to each point, we're going to draw a line. We can connect all the lines, but it might be confusing. So let's do it one by one. So we collect from the first point, W, to the point of rotation, we draw a straight line. Then setting our protractor or center on the point of rotation, as we learn in construction, we mark off for 90 degrees on our protractor. Then getting our compass, we're going to extend from the point of rotation to the point. Ensure that it's properly set. So we open our compass from the point of rotation to our first point, and we create an arc. Now we can see where we had marked off our 90 degrees here. Hence our 90 degrees would fall on our arc right here. So when we set our protractor, realize that we'll get 90 degrees right on the arc right here. So we'll do the same. We'll connect from the center of rotation to the next point. We'll draw a straight line. Open our compass to the distance from the point of rotation to that point, and we create an arc or semicircle. Then we take our compass and set it on the line, set it at this point of rotation, and measure off 90 degrees to our right. Turn wherever it touches the arc, that's where our x prime will fall. So this would be our w prime. This is our x prime. So we'll do the same. So from our center of rotation to the next point, the y point, we draw a straight line. So first we connect the point to the center of rotation, then we get our compass, pivot at the center, open to the distance of the point, and then we swing to create our arc or semicircle. Then we get our protractor, set it at the center of rotation. Remember, the baseline should sit on the line that you have drawn. Then we read off 90 degrees to our right and anywhere on the arc. So that's our next point, and this will be y prime. So we have x prime here, w prime. See our points coming out. And then now we draw another straight line from the center of rotation. So first step, we draw a line from the point to the center of rotation. Second, take our compass, pivot on the center of rotation, open to the distance to the point, and since it's a clockwise, we'll swing to our right to create our arc. Make sure we get our distance properly. So see, it's open to the distance. Then we swing. It's a little bit more there. And we swing clockwise. Then we get our instrument, compass, center it on the point of rotation, ensure that the baseline sits on the line that you have drawn, read off 90 degrees to your right, and we see it fall on the arc, right here on the arc. So what we realize that the point will fall on the arc that you have created, and see we have our image drawn. So you see our 4 points, which is the z prime. So we have just created our image. Sorry about that. And here we have our prime, which is our image, w prime, x prime, y prime, z prime. And sometimes the B part of the question might ask to read off the coordinates for each of the points. So you just look at the w prime and read your coordinates. Okay. So the basic step is to, after you have drawn your object, you draw a straight line from the point of rotation to the point. Then extend your compass from the point of our center of rotation to the point. Create your arc. If it's clockwise to your right, if it's anti-clockwise to your left, then set your compass and read off 90 degrees or whatever degrees is given, and you do that for all points one by one. If you do all the points at once, it might create some confusion, so it's best to do it one by one. Okay, and that's a basic for rotation.